Our first speaker comes from Düsseldorf, Germany. He started working in Python in 1994. In 1997, he became Python core developer. He is also CEO and co-founder of eGenix, Python-focused company. Also, founding member of Python Software Foundation, organizer of EuroPython Conference, PyCon.de conference in Germany, and Python Düsseldorf meetup. His contribution to Python community is really enormous. Let's listen to the keynote opening our conference. Python community, present, past, and future. Please welcome Marc-André Lemburg.
Thank you for the nice introduction. I got invited here by the organizers to do a keynote, and I was really honored to speak at your very, very first event here in Warsaw. So, Konrad, Tomek already told us a bit about myself. I'm going to continue with that a bit. I'm going to make this very short. I started with Python very early on, in the very early days of Python. I also studied mathematics while doing that. I run a company. I'm a software architect, and I'm, well, kind of engaged in the Python community. So I'm board member of this Python Software Foundation, board member of the EuroPython Society. And I like to push Python forward in the community. And that's what I'm going to talk about here today. So when the organizers asked me to do a talk about the Python community, I thought to myself, well, it's kind of difficult to talk about something that you have to feel. It's not something that you can actually describe. So my approach to this talk is going to be that I'm going to tell you a bit about how I got into the Python community, and maybe you can see certain things there that you've experienced as well, and I think that others have experienced too. So that kind of makes it kind of approachable, more approachable to get this feeling about the Python community and what it's all about. So when I started programming in the early days, I used to do programming in C. And C is a very nice language. It runs very fast. I love performance, so it kind of fit my needs. But the problem with C is that you have to really start at the very basics. So you basically take your atoms, like your integers and strings and stuff. You have to put everything together using strings, using pointers. So you first build your atoms to work with, your molecules then you put everything together into larger blocks, building blocks, functions, data structures, these things. You have to build all of these things yourself. And then you put everything together, you build these brick walls, you put everything, you use lots of cement, you use lots of strong typing, lots of very tight bindings between the components that you have in your application. And then you can use a complex IDE, a compiler, a linker, put everything together, build large things with it. It takes a lot of time, it takes a lot of work. You usually need a lot of people to do things. And then you end up doing interesting things like these, which is maybe not that exciting. So you can do your work, but if you want to grow up, if you want to build enterprise kind of things, then you need lots and lots of people, lots and lots of teams. You have to work in parallel with lots of teams to then actually make things happen, like these buildings, like enterprise kind of applications. And not only that, the path to that goal, to that success is very rocky. It's not a smooth thing, it's not a smooth experience. You always have to fight against the technology. You make lots of mistakes, you get seg faults, you have to go through all these phases with the compiler, and then you get a bug report, and then you have to try to replicate that, and it's always very difficult doing that in C. Plus, you have very, very strong predefined structures that you have to adhere to, so there's not very much flexibility there. If you do something, if you want to get out of these structures, then you have to put in a lot of effort to make that happen. So everything is kind of bound and predefined for you. And plus, of course, you hit lots of brick walls along the way. So it's not free programming. You cannot just take your idea and then turn it into code. You actually have to work around many of these things, and so it's not a very nice experience. So when I first got to know Python, I learned about Python. That was it was sometime in 1993. I bought a freeware CD for OS2. How many of you know OS2? I cannot really see anything here, but probably not that many. So I was very much into OS2 because I liked that operating system. At the time, it was a very new operating system. It was very interesting because it had many, many new features in it. And so I looked around a bit what kind of things that were available for OS2, and someone had ported Python to OS2, so I found it there. I had a look at it. I read Guido's tutorial on Python in just an afternoon, and then I got completely excited and basically never looked back. So with that in mind, that I came from C programming, I had all this hard time doing C programming, and I then learned about Python. I learned about all these nice things that you can do in Python. It was pretty much like just blue skies for me. So it was a complete new experience, a complete new revelation for me to start working in that programming language where I don't have to think about all these details. And most of all, I get all these basic building blocks for free. So I don't have to think about pointers. I don't have to think about memory allocation, all these things. I cannot make that many mistakes programming in Python. So I get the dictionaries, I get the lists for free, I get the classes for free, the objects, instantiation, all these things. Memory allocation is being done for me. So that's very nice. Plus, it's possible to build things very quickly. So you can, if you have an idea, you can just sit down, you can program things, you can try things out, you can throw away things very easily because you don't have to write much code to do these things. And so you can try different concepts, you can play around with your concepts. It's not like in C where you always have to spend a week to try a new concept and then you find out that it's not working for you. So you can build many different prototypes and then just have a look at those prototypes and try to pick the one that you actually want to use, that you actually think that might be a good idea to move forward with. Plus, I learned a completely new concept, which was something that I always wished to have. I learned about loose coupling, which basically means that you don't have these strong bindings between the different components in your architecture, in your designs. So you can develop one component in your architecture and then you can replace it with other things easily without having to touch all the rest. That's not very easily possible in C. It's not very easily possible in C++ or in Java for strongly typed languages. Python makes that very easy because it does duck typing, so you don't have these kinds of strong bindings between your components. And so getting used to this was, it took a while because it was kind of a new freedom. I needed to get used to it, to find out how to actually put it to life. But in the end, it worked out really well for me. And so you can quickly come up with nice designs. You can build your things. They actually work. You can actually run them. If you put in some more effort, then you can make them higher performance. Getting higher performance in Python usually means that first of all, you have to optimize your structures, the way that you build your components. But you can also move to C programming again. So you can have your C extensions, and that's what I did at the time. I wrote lots of C extensions for Python to get a bit more performance out of Python. But you don't have to do everything in C. You can just put the performance intense things into C, and then you can do all the structuring and everything and putting everything together. You can do that in Python again. So that's very nice. Plus, it's possible to build really big things. So you can have large structures, you can have many, many components in your applications, put everything together to build enterprise-scale applications using Python. And so to compare that to the C experience, it was a very interesting experience because you could actually take your code and take your applications and build really nice things, build enterprise scale things, but nice looking things. And there was nothing preventing me from doing anything. I could just start programming, and there were no brick walls that I could hit. I could just continue working and focus on what I wanted to do. So that was kind of the experience that I had when I first learned about Python and I entered this whole Python ecosystem. Of course, at the time, the community was very small, but it turned out that the community is actually one of the major advantages that Python has, especially over other languages, because there are other languages like, for example, C or Java. They don't have these kind of communities that are really friendly, open, and really helpful. Usually feel like, I don't know, a drop of water in an ocean. So it's not this kind of close relationship that you develop. Of course, everything started small at the time, but it grew kind of quickly because more and more people came in, more and more people liked this approach that Python had to offer compared to other languages. And we came up with a community that was really colorful. So we had very interesting personalities in the community, or we still have very interesting personalities in the community. Like, for example, Tim Peters, or Mark Hammond, or Raymond Hettinger, or Alex Martelli, or Anna Ravenscroft, or Laura Creighton. Do you know these people? Yeah, have you seen them? Raymond, for example, he does excellent talks, much better than I do. And those people really make a lot of difference because those people are actually putting a lot of energy into the community and make everything work. They're very, very helpful. They're very, very smart people. Of course, I forgot Guido. And in the very early days, it was very interesting for me to actually be able to directly have email exchange with someone who designed the language. That was a very new experience for me as well. And all the other people, like Tim Peters, for example, who's basically a genius, he was very approachable as well, and that was new for me because I came out of university, and university you have the professors, and I mean, if you want to talk to a professor, you got to go to the secretary and then get an appointment and then maybe have a meeting, 5 minutes or so. And with these people, it was very straightforward. You just sent an email, they replied to you. That was a very nice experience for me. And so what we have now is we have a very large community because people love to come into the community. They love to join the community. And it's also very international. It's very, very healthy, I think. If you look at a map of all the events, these are all the events between 2012 and 2015 happening in the Python community. You can see there's a lot going on worldwide. I was especially surprised to see how many events we had in Europe, because before seeing this, I always thought that most of the community stuff was actually happening in the US, but apparently it's not. You have lots of things going on in South America, a few things going on in Africa, not that much. India is coming on strongly, Asia is coming on strongly, and of course we have Australia and New Zealand with a few conferences as well. So this is a very, very interesting development that we're seeing here. Now let's have a look back at how all this started. I made a few charts here that show the kind of the development of the Python community, how it grew. So it all started, I don't know if you can see that, in 1991. That's when Guido released the sources of Python as open source. At the time, open source, the term was not really, it wasn't a term yet, so he basically did open source before it was invented. So he released the sources to the newsgroup Altsources. That's how people used to release stuff back in those days. So he just sent, I don't know, 13 archives, tar archives to Altsources with the source code of Python. And then it slowly picked up. People just kind of took the code, tried it on their system. In those times, it was basically Unix only, and later on, it was ported to MS-DOS and then Windows. Mark Hammond did a lot of that work to make it work on Windows. And over the time, things started to develop. First, stayed very everything was very small. There was a first workshop there. It had I think, 50 people from just basically the US. And then it continued to grow, and it continued to grow in different areas as well. For example, there was a lot of emphasis put on the web, because at that time the internet was basically booting up. And so we even had a browser written in Python, which was very interesting because you can have applets running in your browser in Python at that time. How many of you know Grail? No one, right? You can still search for it. I think you can even download it, and maybe you have to use, I think, Python 1.3 or something to actually make it run. That was an interesting experiment. It was basically an experiment run by Guido to check whether Python is really useful to write larger applications. And it turned out it was really useful. It worked really well. The only problem with that was that it used TickleTK for the GUI side, and the text widget in TickleTK was so slow that it was basically, I mean, you could run it, but it wasn't a nice experience. It wasn't as good as Netscape, for example, at the time. And that was the website. And then, of course, we had the scientific side. Now, I can't tell you very much about the scientific side because I've not really done much in that area. I've mostly worked in the website. But there was an extension developed at that time called Numeric. You probably have heard of that. It's called NumPy right now. And it was started at that time. People took Python to do really serious number crunching stuff. Python was ported to the Cray at that time, and they actually ran their calculations on the Cray using Python, which was kind of amazing. I mean, Python itself was not that fast, especially not from number crunching stuff, but with this numeric extension, it was possible to actually run everything in parallel, and you could do large matrix calculations and these things. So people got really excited about this, and people are still using that, and it's growing really probably just as much as in the web area, but again, I cannot really say anything much about it. At that time, the PSA was started, the Python Software Activity Group, which was something like the PSF, but in the early days. And so you could just sign up there, you had to pay a yearly fee, and then you became a member. That was something to support Python going forward. Around those times, the first applications in the commercial area started to use Python. I think the very first commercial app that actually used Python in production was the WebLite, web-based shopping system that eShop developed at that time. They got bought by Microsoft. And Greg Stein was one of the core developers at eShop. And it was interesting, I found a paper on this eShop system. And in that paper, he already mentioned the problems with the GIL. As you can see here, they were basically working on Windows. So on Windows, you usually have to, if you want to run things more quickly or you want to scale up, then you have to use multiple threads. And he found the problem with the GIL that only one thread can execute bytecode, Python bytecode at any one time. Found that to be a major roadblock for him. And so in those days, he actually started experimenting with turning Python into a free threaded program. For some reason, I don't know exactly why, because it's not really clear. I couldn't find any document about what the reasons were, but for some reason it didn't work out. He started working on it, but then eventually just dropped it. But it's interesting to see that in 1997 he already realized that this is going to be a problem. And obviously we still have that problem, and we need to do something about it. Then Python development continued, and we had several waves of applications coming and going, bringing more people into the Python community. So the first big wave was the ZOAP web application system. And that was also one of the first major open source applications that we saw in Python, completely written in Python. So that was started very early. That was started around the internet bubble kind of phase. So they got seed funding, like everyone else at those times. And actually the company itself didn't want to make it open source. It was actually the venture capital company behind it pushing them into open source, because open source was very hip at the time. Everyone wanted to use open source. I don't know if you remember VA Linux, the company that was very big in that in those times. Later on, they dropped the Linux again in their name, and then they folded. So around that time, Zope was very big. The Python consortium was founded because people actually started putting money and betting money on Python. So there was a need for companies to actually invest into Python, and you could become a member at those days for I think 10K per year. So companies like HP, for example, became member of the Python consortium. And that Python consortium then also paid for some of the developments in Python. For example, the Unicode integration stuff was partially paid by those companies. And then in 2001, the PSF was founded, which was the successor to both the PSA and the Python consortium, and that's what we have nowadays. And around that time, the conferences that we had in Python, we used to have just the workshops in the early days, and then later on we had the IPCs, the International Python Conferences. They were organized by a company called Fortec. They then did not want to continue doing that because they couldn't make any money on it. And so the community back then thought that, well, we can do this ourselves. We don't need a company behind it. We can just get together a few volunteers and then try to work out things that way. And that was the first major event doing that kind of approach, using a community-based approach, was EuroPython. And then in the following year, PyCon US was founded and was then launched, and PyCon US grew very quickly. EuroPython grew as well, but only in the last few years it's gotten to a really a point where it can actually compete with the PyCon US conference. And later on in the later years, other conferences, PyCon conferences popped up. And right now, we're seeing lots and lots of new PyCon conferences pop up everywhere around the world, as you've just seen on that slide with the events. So after Zope, the Zope wave, the next wave was Plone. And Plone brought in a lot of new people, also a lot of new companies. And of course, nowadays we have Django. And Django is basically the huge kind of motor, the engine that's bringing us new people into the community. And that's very important because we always need these kinds of motors bringing in new people. And I don't know what the future is going to bring. It's probably going to bring a new wave. There's going to be something new that's very big, bringing in new people. If you look at down here at this small blue line, I don't know if you can read it, you can also see that the numeric side, the scientific side, started ramping up a lot. So numeric was folded into with NumArray, which was a competing kind of implementation of arrays in Python. It was folded into NumPy. Then the next big thing was pandas and the IPython notebook. Do you know pandas and IPython? Yeah? That's very good. Those are excellent tools, really good tools, because especially for scientists, they don't often know very much about programming, but they are very used to tools like MATLAB or Mathematica, and pandas and IPython, the IPython notebooks, they make these analysis things really easy for them, so they can really focus on the results and their ideas rather than having to focus on the programming. And plus, of course, it's all written in Python, and Python itself makes it easy for them as well. So that's very helpful to get more people attracted in that area. So yes, right now we are at this red line here, and so the next big thing is, well, pretty much unknown right now. I have a few ideas of what we could see in that area. I think it's very important for us to keep looking for new things and keep looking for new ways of growing the Python community. Because over all these years, I've been to lots and lots of Python conferences. I kind of saw the whole community grow older, and not that many young people come into the community. So in the last few years, there was a new development. I don't know if you've heard of that. It's called Raspberry Pi, so you can actually program these things. And that was being developed by a foundation in the UK called the Raspberry Pi Foundation. So they make these small little devices, which are very cheap. So it's very easy for kids and for schools to get them to teach their pupils or to teach the children to program. And luckily enough, the Pi, although it's written differently, the Pi in Raspberry Pi actually stands for Python. And Python is the main development language on that platform. So that's very, very useful for us to bring in new people, young people to the Python community. And I think that's very much needed because the community is growing too old. And because we have so many people run on mobile platforms and Python's story on mobile is not that great, it's important to get these people at a very young age to get interested in Python. So this is a good way to move forward. And then, of course, we have to look at all these white areas that we have here on the map. And we have to grow in that sense as well. So we have to grow internationally. We have to pick up more people. For example, there are lots and lots of people in India who could benefit, especially from these Raspberry Pis, to learn programming. Lots of people in China. Africa is pretty, well, there's not so much going on. There's a lot going on in South Africa, and we have a few countries in Africa now starting PyCon conferences as well at a very, very small level, like, I don't know, 20 to 50 people. But we have to keep looking to engage with these people. We have to make it easily possible for them to run these conferences, help them. The PSF is doing a lot in that area with giving people money to run these conferences, to overcome the first hurdles in running these. So this is something that we need to focus on. And as you can see here at this conference, this is exactly what we need. We need new conferences with new people coming in, and we need lots of those to continue to grow. Like I said, we also need to focus on some other things like going mobile. Python on mobiles, well, currently just has Kivy, the Kivy framework. If you've used Kivy? Yeah, a few. That's good. I tried it too. It's a really nice system. It's a bit slow on startup though, so that is something that would need to be addressed. There are also some other activities going on to make it easier to port Python to Android, for example, or to iOS, and integrate it better with the platforms. There's still a lot of work going on in that area, so this is going to be big if we can make it actually work nicely. The next big thing is PyData, so basically the big data for Python. This has to do a lot with pandas, with the IPython notebook, with NumPy. Lots of people are putting their data into these systems and then plug everything together using Python, do the analysis using Python. And so putting a lot of energy into big data would bring Python forward a lot, I think. The same goes in the other direction, so you can also scale down to microcontrollers, for example. This little chip runs Python 3. It's a microcontroller that you can, it's very cheap. It's sort of like the Raspberry Pi scaled down to, I think it costs 30 pounds or something, this chip. And of course, if you buy larger quantities, it really makes sense to buy these things. And what's really exciting about it is you can open up a serial port to it, and then you get a Python 3 prompt, and you can program it like that. So it makes it really easy. Plus, you can connect all your hardware to it, and this is a really nice development. Have you heard of that one? Just a few. You should definitely have a look at it. Just Google for MicroPython. It's a special kind of Python variant that was adapted to these microcontrollers, so they ripped out a few things and limited Python a bit, but as a result of that, it runs on very low memory. It runs, well, not really fast, but I mean, for a microcontroller, it's fast enough. So this is really interesting. Right, those were the different application spaces that we have. Of course, we must also continue to develop the technology. Like I already mentioned, we need to do something about the GIL, because right now you can have 1,000 cores, but Python bytecode is only run by a single core of your 1,000 cores. And so this kind of problem is something that we need to tackle in the next few years, because we ideally want to run on all the cores that we have, right? And then, of course, we have lots of competition from other languages, like, for example, Java, or maybe JavaScript would be the better analogy here. Lots and lots of people are going for JavaScript. JavaScript has gotten really fast in the last few years because of all these compilers, the JIT compilers. Python is working on that as well in form of PyPy, where we also have a JIT compiler and runs fast. So that's already a good development, but we still have this GIL issue. Then, of course, you have other languages that were specifically designed to run very well in a concurrent kind of environment, like, for example, Go, or the new language that's already rusty, Rust, developed by the Mozilla Foundation. So we have to keep these in mind when looking forward. We have to address the issues that these languages fix in order to stay competitive with everyone else out there. And of course, we have to keep reminding us that it's all about fun. Some people, I've seen some people in the Python community take things too seriously, well, especially in recent years. We have to remind ourselves that Python really comes from Monty Python. So the fun is sort of like built into the language, and we need to keep reminding us of that, and then not take things too seriously. And always, take a look on the bright side of life and enjoy things. And that's all I want to say. Questions?
Thank you very much for this great keynote, Marc-André. I would like to start with one question. Like I've mentioned, you are a member of the Python Software Foundation. You're organizing some conferences and running a meetup in Düsseldorf. And could you tell, what is the thing that gives you the biggest satisfaction when, running Python community? What do you enjoy the most?
The biggest satisfaction is really seeing people get excited about Python, and seeing. If you talk to someone at, for example, the Python meetup that we have in Düsseldorf, we have new people coming in regularly, and if you talk to them and they get all excited about how they learned to use Python, and you see that Python made a difference for them. And that's a very nice experience. The other things, like, I don't know, being a director of the PSF is not really that exciting. It's not, you get grant requests, you have to look at the grant request, you say, okay, you get the money, and that's it. So it's not exciting in that sense, yeah. But actually talking to people and seeing that people get excited, that's really
okay.
Nice.
So you enjoy the low level more.
Yeah,
the high
definitely.
Level. Okay. Are there any questions?
Here. I would like to ask if you have any theory why Python has such a strong community. Because I heard, for example, about Ian Biking, who left Python for JavaScript. And I think JavaScript is also enormously popular. There are much more people programming in JavaScript than people programming in Python. But Ian said that he doesn't feel this community like in Python. So I would like to ask if you have any ideas why Python was such successful on this level, on the community building level.
Well, that is kind of the question I asked myself when writing this keynote. It's difficult to answer. I think it has lots to do with the friendliness of this community, with the diversity of the community, that it's very international, that people come into the community from all kinds of different perspectives, whereas, for example, in JavaScript, I think the main perspective is that people come into the community from a commercial side. I think that makes a big difference. I mean, the community itself developed out of a very small kind of circle of very smart people, and everyone was extremely friendly. And I think as the community grew, that friendliness kind of spread, unlike with other languages. For example, I've talked to Iron about this, and I've also talked to other people about this who basically went from, for example, from Python to Java, or came from Java to Python, or JavaScript. The difference there is not really that big. I mean, the problem that they have is there's nothing kind of, I think it has to do with having central kind of development, kind of a core developer thing, and then you have people using those core developments, and you feel that people from the community can go to the core developers and ask for things to get new features in. And everyone is very open about these things, unlike with these other languages. And I think that makes a big difference. But again, I mean, it's not really a good answer, I know, but this is kind of what I think makes the difference. Plus, I mean, fun is built in. It's not necessarily built in Java or JavaScript, right? I mean, we have the Zen of Python. I don't know if something like that exists for JavaScript or Java. So we have a Tim Peters. I don't know if they have a Tim Peters.
Hi, Tibor here. So one remark, I'm from Slovakia, and I know a lot of young people and not very many older people engage in Python. So I think it's perspective of the most developed countries, maybe that the community is growing maybe old, but I don't see that. And my question is, you showed the graph with Django being after the peak. Do you really feel it like that?
Yeah, I knew that question would come. Actually, the graphs are just made up by me. So I just basically the idea behind that was a wave, not so much that you reach a peak and then you go down again. Let me just try to find that slide again. I'm not really sure whether Django has already reached the peak, but I've seen it with these other technologies, so I think that we kind of need to prepare for that. I'm using LibreOffice, it's kind of slow. Sorry. There you go. Yeah, because I've seen it with Zope, for example, with Plone. I mean, Plone is still there, of course, and they're still developing new things. For example, there's Plone Intranet now, which is picking up. But but you can see that people go into a technology, they start to use it for a few years, and then they see that there are other technologies. For example, Plone came after Zope. I mean, Plone is built on Zope, but still it's much more usable, so you get more people coming in that way. And also the wave is not so much about, it's about people coming into the Python community. It's not so much about the technology being bad or being poor or whatever, have deficiencies or anything. Because, I mean, Zope is still there, it's still great software. Plone is still there, it's also great to use. And so this is not so much about whether the technology is good or bad, or whether it has gotten old for some reason, it's not being developed anymore. It's more about how many people do we get into the Python community using that technology. So I don't want to really make a statement about whether Django is on the decline or not. I think it's still thriving. I think it's getting better with every single release. So.
Are there any other questions?
I have a question for you. What do you think the next big wave is going to be? Something asynchronous. Yeah, that's good. Yeah. Everyone is talking about asynchronous now.
Can you pass
Tornado,
the microphone, please? Can you repeat?
Oh yeah, no, I just believe in asynchronous programming. in Python right now. It gets really cool. Tornado is really nice to use. I use it a lot. So yeah, I believe something in this area would be there.
Mm-hmm.
But
so you think asynchronous is going to be the next big thing that's coming, yeah?
in my personal opinion, but I'm no authority in any way. Just the opinion of a poor guy.
Yeah. Anyone else?
I can answer that question too. In my opinion, support for bigger code bases, so making it easier for us to stay dynamic and prototype as we do in Python, but also maintain large code bases, right? Easier unit tests, test better. So namely, I hope the recently accepted type hints is gonna be a radically big thing.
Yeah, that's an interesting topic, this the type annotation. It's a very controversial kind of thing, because people, one part of the community thinks that these type annotations are going to turn Python into kind of a statically typed language, that people are forced to use these type annotations. And the other part thinks that it's actually a good thing, because it makes it easier for example, code analyzers or compilers to use that information to then increase the performance of Python without having to go to Python or PyPy or any of the other technologies. All right.
Okay, Marc-André will have another talk tomorrow covering large-scale applications in Python. Thank you once again very much.
Thanks.